Greetings all. Okay, so I want to talk about dynamic skill theory, which is a neo-Piagetian theory. And as I go through this, because it's a neo-Piagetian theory is a theory that comes after neo-Piaget's theory and corrects many of the problems that occurred in Piaget's theory. As you read chapters on Piaget, you may have questions, and what I want to do is I want to talk about dynamic skill theory because it's going to help you to understand Piaget. As I talk about dynamic skill theory, what it is, how it characterizes development over time, I'm going to be talking about how it differs from Piagetian theory, Piaget's theory, and then what the basic ideas of Piaget's theory are as well, so that you get a sense of Piaget and dynamic skill theory. Dynamic skill theory is a theory that I've been working with for a long time, and we will be working with it in this class as well. So let's get moving. Dynamic skill theory. It's a neo-Piagetian theory now. So what do we got? So what have we got? That's a quick and dirty indication of how development happens. It starts with one thing, a single set, one action, one idea, one abstraction. And then over time, child or person is able to coordinate, put together two actions, two ideas into a mapping. And then with more time, a child, a student, an individual, an adult is able to put together two mappings together at the same time in order to form a system. And then a person is able to, with further development, put together multiple systems to create a system of systems. This is the type of thinking that we're going to be using here, and you'll see how it works in a few seconds. So here's Fisher's dynamic skill theory. Kurt Fisher, he was at Harvard University, recently retired, passed away prematurely, and he postulated, like Piaget, that development moves through a series of levels. Piaget used the word stages, which is different than levels. We'll see what that means as the course goes along. But what you've got here is, what he's got is three tiers of development. That development moves through an action tier, a sensory motor tier in infancy, a representational tier, it's a tier based on ideas and symbolic representations between ages 2 and adolescence, and then an abstract tier that develops from adolescence onward through life. These are the ages at which these various levels of a skill begin to develop. We'll talk about that as time goes on. Now, an important distinction between Piaget and Fisher. Now, Piaget had four broad stages of development. Sensory motor stage, which is very similar to Fisher's action sensory motor stage here. A representational, Piaget's has a sensory motor stage, a pre-operational stage, and a concrete operational stage. The pre-operational stage is similar to the representational stage in Fisher. And the pre-operational stage it spans what Fisher would call representations and mappings. The concrete operational stage occurs at what Fisher will call systems. You'll get all this later on. And then Piaget has sensory motor stage, pre-operational stage, concrete operational stage. Here's sensory motor, here's pre-operational, here's concrete operational, and then formal operational. The formal operational stage corresponds to Fisher's abstract tier, and these early abstractions are what Piaget called formal operations. Fisher's theory suggests that there's further development beyond formal operations. And the biggest difference between Fisher and Piaget is as follows. Piaget suggested that development occurs in stages of, now what's a stage? For Piaget, a stage is a homogeneous, broad-based, generalized structure of action or thought. What does that mean? That means that when you're in the sensory motor stage, all of your thinking or all of your psychological processes are structured as sensory motor actions. When you're in the pre-operational stage, all of your thinking is pre-operational. When you're at the concrete operational stage, all of your thinking is concrete operational. And when you're in the formal operational stage, you're capable of thinking in formal abstract systems across all of your thinking. So that a stage is a global, generalized thing. Piaget called it structures d'ensemble, structures of the whole. That it's kind of like that people's skills and beliefs and ideas move in these single, broad, global structures. And what Fisher said, and there's plenty of evidence that is against the idea that development moves in these broad stages where your essay writing skills, your spatial skills, your musical skills, etc., they don't all develop in the same pace. They're not all in the same stage, but rather what develops are skills. And what a skill is to Fisher, now this is Fisher now, what skill is to Fisher is the capacity to control elements of thinking and action, capacity to control elements of thinking and action within particular contexts. Okay? You change the context and you'll change the skill. You'll change the element, you change the skill. So in other words, there are different skills and skill domains. A skill is the capacity to control action and thinking within particular domains and within particular contexts. There are no general stages of development. There's only developmental there are always levels of development of particular skills within domains and within context. So you can talk about mathematical skills or arithmetic skills, which may be different from writing skills, which may be different from spatial skills, which may be different from the capacity to engage in sporting activities, which may be different from the capacity to cook a dinner. All of these skills develop relatively independent of each other along their own trajectories in particular contexts. And you can only show developmental levels of a skill within a domain, sometimes only within a task, and only within particular contexts. Okay? There's no such thing as running. There's only running up a hill, running down a hill, running on the beach, running on a track with rubberized cleats, running on a track barefoot. Each of those is a different skill, and easy to show yourself that. Go run on the beach. The entire structure of your running changes. How you organize your body changes. Run up a hill, run up a mountain, run down a mountain. The skill shifts as a function of context. And the level of that skill is therefore going to be different in different contexts and in different developmental domains. Now let's give a sense. That's a very quick overview. Let's begin to get a sense of this theory in action. Okay? So what we've got here in skill theory is the iterative development of skills through three broad tiers. Again, Piaget had four broad stages. Fisher talks of three broad tiers, and he's going to talk about all the Piagetian phenomena within that. So the first tier is the sensory motor tier. Actually, that's a lie. The first tier is a reflex tier that happens very early in life. I'm not going to talk about that. I'm going to pretend that doesn't exist for now. We'll talk about the sensory motor tier, which begins around age 4 months of age. This reflex tier begins at birth. So you've got sensory motor tier, which begins with a single sensory motor action. Looking at the bottle, following the bottle with your eyes, trying to reach for a bottle that is stationary, single actions. And then they move to mappings, a mapping of two actions, the capacity to look at the bottle and reach for it at the same time, or as the bottle is moving, I can coordinate my looking at the bottle and my reaching for the bottle at the same time. I can put two skills together. I can look in order to reach, I can reach in order to look. That begins to develop around 7 to 8 months of age. And then a system. You take two mappings and you put them together to create a sensory motor system. Okay, this is something that begins to develop around 12 or 13 months of age. So I take an object here, this and I hold it, and I put together all types of movements into a single movement of exploration, multiple mappings. I might drop it and see how it goes, throw it, and see what happens to it. Multiple actions together in the same skill. And then that brings us to a system of systems where I can control and bring together two or more of these complicated action systems, and then something very special happens. When you get a system of systems at any level, now each of these tiers, this is just the sensory motor tier, each tier goes through these four iterative steps: single steps, mapping, systems of systems. The fourth level, systems of systems, is the first level of the next tier. So the system of systems, system of sensory motor systems, is the equivalent of a single set in the next broad tier of development, which will be the representations tier. Okay, and then in representations, it goes through the same tier. You get a single representation, you put together two representations, you get a mapping, you put together two mappings, you get a system, you put together two systems, and you get a system of of representational systems, which is the first step of the next tier of development, which is abstractions. And then the process continues to iterate. Okay, let's move on. Okay, so iterative development of skills through multiple tiers. So you got the sensory motor tier, the representational tier, and the abstract tier. The sensory motor tier, my thoughts are not thoughts. I only have actions. Sensory motor tier is defined as the that my thinking, if I have any thinking at all, is the sensory and motoric aspects of acting on the world. What I act, when I'm acting, I'm able to represent the here and now, the experience of the here and now. And it's not until the representational tier that I'm able to think in symbols and representations. I'm able to represent the world when the world isn't there. I'm able to represent the bottle when it is absent. And to represent the bottle when it is absent is the capacity to form an image of the bottle, to make the image stand for or refer to the bottle, or to use the word bottle as a symbolic form, and to begin to be able to think in concrete images and concrete words. The abstract tier, thinking now, does not have to be concrete. In the representational tier, thinking must be concrete in the sense of I can only think about things that I can imagine, that are concrete, that are tangible. In the sensory motor tier, I can think about bottles or particular bottles and drinking particular bottles and how particular bottles pour, but I can't think of bottleness, and I can't think of abstractions, abstractions like inertia, or I can't think of conservation or the like. You'll see what I mean in a few minutes. So what happens is, here's the developmental sequence. In the sensory motor tier, you're starting with early development. In 4 months of age, you could have a single action that moves to, you put together two actions, you put together two mappings into a system, you put together two systems into the system of systems, system of sensory motor systems, which becomes the equivalent of the first step, first single set in the representational tier. Now the child is able to not just act, but to think symbolically, reflectively, using words, using images. And then what happens is that the iterative process continues. It moves to a mapping. I can relate two thoughts. It moves to a system. I can relate to relations of thoughts into a complex system. Here is the Piagetian level of concrete operations. If you will, here's the sensory motor period for Piaget. Here's the pre-operational period for Piaget. Here's the concrete operational period of Piaget. And then the next one, when we're able to put together multiple systems, multiple representational systems, we get of the representational tier turns into the abstract tier. A system of representational systems becomes the first level of the abstract tier. I can think of single abstractions. I can think of the general concept of kindness. I can think of the general concept of a variable, of an algebraic variable. I can think of the general concept of beauty. And then I begin to be able to put together multiple abstractions. I can relate beauty to truth, for example. And then I can relate two mappings together into a very complex abstract system. Beauty is to truth as scientific parsimony is to something else. And then the highest level in Fisher's system is an abstract system of systems, which is a broad-based abstract principle, he calls it. And that's, the capacity to represent abstractly, broad fields of abstract ideas and their relations. There's the basic theory. To put it into practice, show you the concrete. Let's start at the beginning. First of all, you've probably all heard of the Piaget. Now, this is Piagetian now. The Piagetian task, the conservation of volume task, conservation task. It looks like this if you have it. So you get two beakers. Okay, you fill both beakers up to the same level. You ask the kid, which has more, this one, or are they both the same? Okay? Kids from 4, 3, they'll be able to do that easily. You'll be able to say, oh, they say here, these two are the same. Then what do is you take one of the beakers and you pour one of them, which is, these two are tall and thin, and you pour one of the tall, thin beakers into a short, fat one. Okay? And then you say, you've got the two of them there. I hope you could see this here. Here's the tall one, here's the short, fat one. You get to say, which of these has more water? Which one has more volume? Kids under the age of 5, 6, or 7 will compare the heights of the water and say that the one with the taller one has more water, and the shorter one has less water. Or less frequently, they will compare the widths and say the one that is wider has more water than the one that is thinner. But mostly, 4-year-olds, 5-year-olds will say it's the taller one has more water. 6 and 7 and 8-year-olds are able to solve this problem, and they're able to say that they both have the same amount of water. So it's when children are able to pass this conservation task, when they say that they both have the same amount of water, that's the entry into Piaget's concrete operational stage. Okay? Prior to that, it's pre-operations. So Piaget's system goes from sensory motor, I'm acting, to pre-operational, which means I can think independent of my direct actions on the world. But for Piaget, my thinking is illogical in the pre-operational stage. It is pre-logical, pre-operational. I can think about concrete things, huge advance over sensory motor, but I can't think logically. So this is why for Piaget, the child fails the conservation task, the 4-year-old, the 5-year-old, because they don't understand the logic yet, that if you pour one into the other, it's still the same liquid because nothing has been added, nothing has been taken away. They can understand that logical operation of conservation. The 4 or 5-year-old can't, the 6 and 7-year-old can. When the 6 and 7-year-old can, they pass into the concrete operational stage. And here's why: conservation of volume. Changes in height when the kid is able to figure out that conservation and the quote-unquote concrete operational stage, they realize they're not just comparing the height, this height to this height, saying this is more. Or they're not simply comparing the width here and saying this is wider than this, or this is more. They're able to see that changes in height from here to here are compensated for, are made up for by changes in width. So that's where the logical operation is born at this point. When the child is able to not just do one mapping, which we will come to see, map the heights here, but instead can see the relationship between changes in height and changes in width, and see that they've got to be the same amount because changes in height are made up for by changes in width. Now you've got, in Piagetian terms, concrete operations. In Fisher's terms, you get representational systems. You'll see that in a few minutes. So let's go through all the levels of Fisher. Again, I'm going to tell you their relation to Piaget, and how Fisher's theory is actually much more precise. Let's start with the sensory motor tier. And what we're dealing here is with the conservation volume task. What does a baby understand about conservation or volume task? Well, not very much, but there's something. Let's start with the sensory motor tier at 3 or 4 months of age. Well, what can babies do with single actions? Well, they can reach for a bottle. Okay? That's related to what's going to come later. Babies can reach for a bottle. Okay? Or they can look at a bottle. Okay? They can see a bottle pour. Okay, they can see it. They can't necessarily imagine that when that's not there, but when they're seeing it, that's the action of seeing the ball, seeing the bottle pour, holding the bottle, reaching for a bottle. 3 to 4 months. So there you go. What we've got here is I can reach for the bottle. So here, this person here is holding the bottle for the infant, and the infant is clumsily reaching for the out. Single act, single sensory motor act. Okay, let's go to the next step. Around 7 to 8 months of age, infants can put together 2 such single acts into a smooth mapping. They map one act onto another. So they can reach for the bottle in order to look at the bottle, or look at the bottle in order to reach for the bottle. So it looks something like this. Somebody's holding it, and the baby reaches for the bottle, coordinates reaching and looking, coordinates reaching and looking. I'm looking and looking. Here's a change in look. I look one way, I look the other way. I look one way, I look the other way. I look one, and I reach a fact. I'm coordinating, reaching, and looking into the same act. 7 to 8 months of age. And at 13 months of age, 13 months of age, you're going to get the baby able to do multiple such mappings, coordinate them together. So the baby might hold the bottle and turn it in one way and see the liquid turn, and then hold it and turn it in another way and see the liquid turn. So it might look something like this. There's the sensory motor system where the child is exploring changes in the water level. See that? Multiple times, over multiple times. Seeing how it differs, coordinating, looking and reaching while looking at the level go up and looking at the level go down, turning it around, dropping it, picking it up, all as part of one skill. Sensory motor systems. Next level. You put 2 of these complex systems together into a very complex interaction. I'm not going to talk about all that funky stuff there, but I'm simply going to say that that is the equivalent, as I'm beginning to do some complex interactions. Now I'm able to actually coordinate these actions with a different set of actions, an image or a word. I can say the juice spills. Now what I've done is I've constructed the first level of the representational tier. I'm no longer in the sensory motor tier alone. Once I'm able to put together many abstract actions together, including the action of saying juice or gesturing toward juice, now I have representations. And the representational level is the capacity to think, to represent symbolically, to make one thing stand for something else, in this case the term juice, and spills for the action of juice spilling. Now representations are born, and I'm in a fundamentally qualitatively different tier of development. And now this first step, here's the first step of the representational tier. The juice spills. So we're now in the representational tier. Juice spills, 18 months of age, 2 years of age, 18 months of age. The glass, oh, that's a big glass. There's a lot of water in there. That's a tall glass. Okay? Same thing. One single idea, which corresponds to a single declarative sentence. There's a lot of water. That's a big glass. There's water. The water pours. All one idea. One idea. And then, by 3.5 to 4 years of age, we get the capacity to coordinate 2 ideas, 2 concrete ideas. So now the child, the 4-year-old, 3.5, 4-year-old, can compare the height of one to the height of the other one. This one is taller than this one. This one is taller than this one. Here's a tall glass and here's a short glass. This is taller than that one. And this is why the 4-year-old fails the conservation task. In these two stages, these two Fisher stages correspond to pre-operations in Piaget's thinking, pre-logical thought, according to Piaget. What we see when we look at it more carefully is that the thought isn't quite pre-logical. It may be pre-systemic, but it's not pre-logical because babies the 4-year-old can understand all types of relations. It's a logical relation to compare one is taller than the other. If I have two dolls and one doll hits the other doll, and the other doll says, "Oh, that hurts." Using mappings, the child can say, "Oh, one doll caused the other doll to get hurt." That's a logical relation. So there is logical relations. I think Piaget was not quite right about that. Fisher would say he was not quite right about that. But nonetheless, these are the two levels that would correspond to pre-operations in Piaget's theory. The next one corresponds to concrete operations. Now I can put two of these together, two mappings together. So not only do I understand that this is taller than this, but this is wider than this, and that height changes in height. The mapping from tall to short is compensated for by the mapping from skinny to wide. And now I've got the capacity to solve the conservation task. That's what happens there. And that's concrete operations in Piaget, and representational systems in Fisher. Next step, not going to go through all the craziness of that, but if you will, if I can understand conservation of volume, well, there's also other tasks like conservation of number, conservation of space, all different types of conservation tasks. And if I can coordinate a representational system for conservation of volume, which we just saw, with a different one for conservation of number, which you'll read about, I put them together in the same skill. Well, now I've got an abstraction. Here's conservation of number, here's conservation of volume. With conservation of volume, we've talked about that. Conservation of number is very similar. You have a whole bunch of these houses here, and you have a whole bunch of houses down here. And you're supposed to have three rows here. So if you had 2 rows of the red ones, and you say to the kid first, well, which one has more houses? They'll say, well, they're both the same. Or which one is longer? Which one is longer? Well, they're both the same. And then if you pull them out so that it looks like the bottom, the second row looks like the bottom. Well, you say, well, which one has more houses? Oh, this one does on the bottom. Which one is longer? Well, this one is on the bottom. That's what the young kids would say. But the older kids, the 5 to 7-year-olds, etc., will say that they both have the same number of houses. They're both the same length because all you did was spread them out. That's 7-year-old stuff. 11-year-old stuff is the child understands conservation of number and the child understands conservation of volume, is able to abstract what's common to both of those. Abstract what's common to both of those. And when they abstract what's common to both of those, you get the general abstract concept of conservation. The concept that quality of the thing remains the same despite a transformation in its appearance. That's an abstraction. That's an abstract concept of conservation. This concept of conservation here at the systems level is a concrete understanding of conservation. The child can understand conservation of water or conservation of number when the water beakers are sitting right there, when the numbers are sitting right there, but can't coordinate both of their understandings into an abstract, generalized, content-free idea of conservation in general, because conservation in general is abstract. It has no content. It's like algebra. With algebra, what you've got variables a plus b equals c, where a can mean anything. It can mean glasses, it could mean water, it could mean number, it can mean discs, it can mean houses, it can mean roads. It doesn't matter what it is. A plus b equals c. The capacity to represent things abstractly is coming around age 10 to 11. With the now entry into the next broad tier of development, what Piaget would call formal operations, what Fisher's calling abstractions. And here, you get the same iterative thing. Around 10 to 11 years, a child can begin to represent abstractions, like conservation in general. Conservation in general is the quality of the thing stays the same despite a change in its appearance. Or abstract concepts like speed. A 10 or 11-year-old will understand speed as how fast something goes. Now things are going to get more differentiated and integrated. I hope you could see that differentiation and integration are going on this whole time. You got differentiation is 1, integration is 2, further integration, then hierarchic integration at each stage. How fast? So at the next level, a child can, the adolescent at 14 to 15 can put 2 of these abstractions together, for example, and understand that perhaps the concept of velocity, which is the relationship between speed and direction. Speed in a direction is velocity, and now the child can be able to understand that. Perhaps the child will be able to understand speed or direction at 10 to 11 at single abstractions, but not both coordinated into a single understanding, which is happening here at 14 to 15. At the next level, you're able to put together multiple mappings. Now look, do you see how differentiation and integration is going on here? Here's a single differentiated abstraction. Here's an integration of abstraction. Here's further integration of abstractions. You might even call it a hierarchic integration. All of them are coming together into one, functioning as a single unit. That's what happens at each level. So here you put 2 of these together, you get the relationship between what force is, F equals ma. Force is mass times acceleration. So what's mass? Is mass and versus acceleration. You've got changes in velocity, changes in time related to the heaviness and resistance of the object. And then beginning around 23, 25 years, people, young adults, can be able to put multiple of these types of things together into very broad sets of principles that, entire fields relating inertia to force, where inertia is related to changes in motion of the objects, et cetera, et cetera, et cetera. And we have broad-based principles. Newton's laws of motion, for example, would be if you understand all those laws and how all those laws are related, well, that's a very complex thing to do. You're able to do that without props and things like that, without support. That is a high level. Again, so each of these levels is a level of skill in a particular domain, perhaps even in a particular context, that develops as the skill becomes more differentiated and then more integrated over time. One idea, 2 mappings, mappings of mappings, more integration, mappings into systems, more integrated, mappings of systems into systems of systems, still more integrated, and then higher level of transformations of qualitatively different ways of being in the world are occurring. To be able to only act in sensory motor actions is fundamentally different than to be able to think and represent the world independent of those actions in the representational tier, which is different than the capacity to think and represent the world in abstractions and to guide my actions with abstractions. For Piaget, sensory motor, pre-operational, concrete operational, formal operational. Thinking is not thinking, but in infancy it's sensory motor actions, very similar to Piaget's, to Fisher's sensory motor tier. Then it goes into a stage of pre-operations where all my thinking is across the board is pre-logical. That would correspond to Fisher's representational first and second steps of the representational tier. And then concrete operations in Piaget, Fisher's third representational level. And then fourth, formal operations is Piaget's final stage, which corresponds to the early sets of Fisher, but Fisher's theory continues to go beyond that to be more precise. I hope that helps you with Piaget a little bit, and I hope that this gives you a sense of what Fisher's theory is about. You have this video now to always look back and go back at what Fisher's theory is saying, because we're going to be using it. I want you to learn this. It's not beyond you. It can be done. Thank you.